So I am making an RPG for the Bruised Egos Game Jam, and I will be rolling with the game engine known as Godot. It is known as a poor man's Unity, basically. Not just because it's free. I mean, Unity is also free, but it is also like it uses a proprietary language known as GDScript, meaning it's built into the game engine, unlike Unity, which uses, JavaScript or C Sharp, which is like separate from the engine, but also you need to get a separate IDE or use a notepad, I guess, for Unity. Anyway, point is, you can't really get a job with GDScript at the moment. I mean, I think Tesla might be hiring for GDScript, I believe, but whatever. I digress. I'm using Godot for two main reasons. One, it's very good for UI, and RPGs are full of UI, and it's gonna just make my life a lot easier using Godot's amazing UI infrastructure because ask any programmer on any project if they want to do UI or GUI or GUI or whatever, and they'll just be like, can you find someone else to do that? I'm, it's just like there's never been a good solution, like not just in games, but just in general for programming interfaces, basically, like just the visual makeup and like having, it's easy to program like the actual like input, but when it comes to like what the how the input is displayed and all that stuff, I don't know, just like it's a whole other thing. Anyway, and the second reason I'm using Godot is it has 3D capabilities. And Unity also has 3D capabilities, but it doesn't have the UI. And if it weren't for the 3D capabilities, I would have used GameMaker. GameMaker has a terrible UI infrastructure and it doesn't do 3D. But I kind of love GameMaker just because GML is a slightly easier language than GDScript, but I have to live with it. But yeah, it's like my only choice. So yeah, I want to make an RPG that is 2.5D, meaning there are sprites on the screen, but they are inside of a full 3D environment. So it's kind of challenging. You can kind of do it in GameMaker, but it's very challenging. And I'd rather just use Godot, which has like an already built-in 3D engine, and it's unlike Unity, works better for combining 2D and 3D assets. So I'll be going with that. So to start off, I'm going to be using two pre-made asset scripts. The Trocara scripts, which is like a third-person, kind of a generic third-person Godot controller for like like physics and slopes and all that kind of stuff. It comes with like a regular 3D character model and some animations, but I'm not actually going to use them. I'm just going to like delete them and use my own sprites for that. And then there's Dialogic, which is like a pre-made message box system. I'm going to be using them for cutscenes mainly. So yeah, for the record, these are pre-made assets. I just sort of like dragged them in. I didn't make them myself. It was just made by other people, but I'm going to edit them heavily. And there's no rules against this. I mean, most game jams nowadays just don't have this, but it used to be back in like 2010. Game jams were very strict. Like you had to make your own game engine for it to be considered its own like its own game. But I mean, I think that I think that the whole thing is like really stupid. Like I think like the game is what you make of it during the game jam. What's unique to that game? Like if I'm gonna do a generic, if I'm gonna make a platformer, I'm gonna use the exact same code I used it for previous platformers. If I'm not copy pasting it, I'm gonna be rewriting it. But once I add my own like game mechanic to it, then it becomes its own game rather than just the basic jumping and moving. In the case of this game, I'm going to be spending most of development just making the RPG battle system anyway from the ground up. If, for instance, someone is using RPG Maker, they already have that built into the game engine. So, it's just hard to say like so it's hard to say like what's the level playing field here when it comes to game jams, but I'm just stating for the record. If anyone's like, "Whoa, how'd you do that so fast?" I just yeah, but I just I just drag some stuff in, whatever. So anyway, sprites. So that's a really fun thing. Godot has a built-in thing called 3D sprites, and they actually work very well because they have a built-in sprite sheet kind of thing you can do. So we're going to actually replace the 3D model with this 3D sprite, and we're going to kind of figure out how we're going to do animations because basically we're gonna have 8 facings. The vertical sprites are the facings, and the horizontal sprites are the animation, the frames of animation. So we're doing a 6 frame walk cycle, full, and 8 facings. Though it's really 5 facings, and you flip 3 of them to get sort of like the front and back are unique, but 3 of the sprites are actually just flipped, basically. So I know I'm putting a lot of stress on myself by making this many frames of animation, this for this many facings, but it's like whatever. So I got a big placeholder philosophy going on here. So what I'm going to do is I'm going to make everything very shoddy and very placeholdery, and just kind of worry about the specifications. So basically, if a sprite is 58 by 58, it's going to be 58 by 58. You know what I mean? I don't make any of that a placeholder, but I do make the actual image itself a placeholder. So if I'm going to have, 6 frames of animation for the walking, in the final game, there's going to be 6 frames of animation for the walking. I have that figured out. So yeah, it's hard to explain what my kind of, it's like a work pipeline thing with game development, where you don't want to be going back and forth in the art and the programming. You just want to have like, okay, I'm putting in a stick figure because I'm gonna not worry about the art right now. I'm just gonna go full speed ahead on implementing some really basic features. So the thing with 2.5D games is that sprites they typically have a billboarding kind of thing where the sprite is always facing the camera, and Godot has a built-in billboarding feature, but there are some limitations with that. For instance, if I wanted to use a shader, I can no longer use the billboarding feature, and I want to use a shader because I'm going to be using that for lighting. What if I want to light the sprite? Which you kind of can, but it's too much to explain, man. I'm just, I'm just basically, I'm using billboarding for now, but I'm going to get rid of it and make my own billboarding shader function later. So don't worry about that. All right, so let's talk about my favorite subject, integer scaling for pixel art. I don't even have anything written for this. I don't have a note for this one. I can just talk about this for a full hour if I wanted to. Um, so integer scaling is when you want pixel art to kind of like retain its pixelatedness, right? We have like resolutions up to 1920 to 1080. I'm actually going to be going for a 1280 by 720 resolution for this game, just because I kind of just want the high resolution for various reasons. The 3D environment and the pixel art aren't going to be pixel, consistent, but just for various reasons, I'm going to go on the safe side and have a higher resolution. But the pixel art is going to be upscaled. And the thing about pixel art is that in 2D, it's pretty easy to upscale. It's just like, okay, just double the size, or make sure it's in non-decimal multiplication. So it's like 3 times the size, 4 times the size, 5 times the size, 6 times the size, but never like 1.5 times bigger than the original size when you're trying to scale up pixel art to be bigger. That's just like just how the world works, is how pixels work. That just, you can't have, like, if every pixel needs to be 3 by 3, um every other pixel needs to do that, unless, I don't know, unless you like look like ugly looking pixel art when all the pixel art is in different sizes and it's really weird. But the dilemma is, when you place a 3D sprite in a 3D environment, it's really hard to control the actual upscaling. In my case, I'm just eyeballing it. So you can see in this like little clip here, the pixels on that ramp, on the little like ramp, the 3D ramp thing, are actually smaller than the pixels of the character. And I'm just accepting that. That's the thing I'm going to accept. But what I'm not going to accept is that the pixels on the text and the character, all the sprite art, should be relatively integer scaled, reasonably and relatively. However, if there's a sprite in the distance, it's probably not going to be very well integer scaled. But I'm going to make sure that the setting in Godot, there's a setting called pixel size, and every sprite in the game has to be the exact same pixel size. But I'm basically eyeballing it and changing the pixel size bit by bit, decimal by decimal, just to make sure that it's properly integer scaled in the result, basically. Um, it sounds like I'm not integer scaling, but I'm basically decimal scaling in order to get the proper integer scale. Um, Integers means non-decimal, but uh, anyway, that's my spiel about like the fun part of pixel art that uh, pixel artists love to talk about. But basically, when you're dealing with 3D, you are going to have to compromise a little bit unless you have a really good like graphics pipeline going on there. But I am not a genius. I am just kind of rolling with the punches and just accepting that hey, the 3D environment is not going to be pixel scaled properly, and some sprites are going to be a little bit jumbled a little bit if they're like in the distance or rotated weirdly or whatever. So now I'm implementing the facings for the sprite, and I'm not going to go too deep into detail, but basically I just take the inputs and put it into a vector 3, and I take two of the values of the vector 3 and convert it into radians and then degrees. And then I divide the degrees by 45 and kind of come up with a number where, depending on what direction you're going in, it'll spit out a number between 1 and 8. And all I do is I just say, hey, change the row of the animation frames to whatever number that number 1 to 8 is based on the direction of the arrow keys that are being pushed in. So obviously this isn't a tutorial. I'm just briefly explaining how I kind of made this stuff. Okay, so yeah, it's facing the direction that we want it to go, but the issue is it's now leaning into the wall. So basically what happens with billboarding is that the sprite is leaning away from the camera. Now you could increase the collision size to make it so you can't reach the wall, but then you get another issue where the sprite won't be able to fit into rocks or something like that. Like what if there's a tight squeeze or a hallway? Then you got another problem. You could make the sprite upright so that it's going upwards, but then it has this very skewed tilt. There's a lot of issues that aren't going to work out unless I do something a bit later. Because right now I have a placeholder like billboard function, and I'm going to make an actual billboard for the shader that we're going to do next. So we're just going to move on and do the actual walk cycle. All I did was basically just write a bunch of numbers along the rows, columns, I guess you could say. But the basic coding for it is just when you're moving, or if any of the keys are pressed, basically, then count up to a number, and when it gets to the max number, reset back to 0, basically, so that the frame coordinates, the x and y of the sprite sheet, are programmed independently, so that the x and y are not interacting or contradicting each other at all. Godot just sort of has this built into how 3D sprites work, so it's very fortunate for me that I don't have to worry about cutting up the sprite sheet in a particular way. It's just, hey, there's rows and columns. You can change what X and Y is independently based on two different numbers going off at once. So it's going to be very important for different poses and different directions. I'm probably just going to have one single pose for one single frame, but with 8 rows of facings for most of the sprites, for most of the animations and stuff like that. But for walk cycle is pretty important to establish what happens when I want an animation across rows and columns, and that's just how it's going to work. So got that figured out. Good to go. Let's move on to the next thing. So I'm going to be going into the shaders portion of the game development process. I hate shaders. I don't like shaders, but I kind of just wrangle them and something happens and I'm okay with it most of the time. So I'm using a cell shader from Train Trip, and it's basically just a shader that lets me have 2 sprites for a character, let's say, or it could be 2 textures for a 3D model, whatever way it goes. One is light and one is dark. And so when you go into a shaded area, it uses the dark sprite, and if you're in a light area, it uses the light sprite. But if you're kind of in between, it'll also like kind of shade it appropriately. So it's very good looking, and I like it because it lets the artist choose what the sprite looks like in the darkness, rather than just kind of like using the lighting engine that's built into the game's engine and just like hoping for the best that the light or the shadow won't like fuck up the colors of the sprite that you have. I'd rather just have, hey, I want the sprite to be this color when it's in shadow and no other color, right? There's a GDC talk from the Guilty Gear people that talks about intention and not result. meaning you don't just leave it up to the game engine or the 3D lighting system or whatever to determine the end result of your colors. You try very, very hard to make sure that the colors are what you intend. Um, for example, if someone draws concept art and they use colors for this particular character, those colors better look pretty damn close in the result rather than just, well, we'll just use a sort of blue and, whatever. Um, I should kind of write a blog post or something about this philosophy, but that's just kind of the gist of what I'm going for the lighting. Anyway, so there's some problems that cropped up. One thing is that the shader does not accept more than one sprite for each of the light and dark samples. So I had to figure out a way to get it so that the walking bright animation and the standing animation were set up in a certain way. This is like black magic to me, and I just sort of lucked into figuring out a way to just change the material that the image is set to, and also change the sprite to what it's set to. So basically, just keep interchanging them, and it will somehow work out. I don't know why it works or what it does, but basically, there's a bunch of issues if you don't do it this way. And I'm just going to stick it to this way. I'm just glad it works, and I'm fine with it. Um, what's cool is that you could kind of do like a weird thing. Like, let's say you have a scar and you only want it to show when the character's in shadow. Like, you can do that. I'm not going to do that, but I'm just saying I could if I wanted to. And that's what's cool about it. It's not just for like colors and stuff. It could just be like, hey, there's like a certain like shine or sheen on the character's hair that I want to hide. Like, the hair becomes less shiny when it's in shadow. So, and it's not like a fancy like shading technique. It's just the artist didn't want the hair to shine when it's in shadow. And I'm both the artist and the programmer, so you kind of get this nice um, intentional thing going on. So anyway, that's how I've set up the lighting, and we're kind of good to go with that. But wait, what about that billboarding problem that you cared so much about and you're totally invested in figuring out how to solve? Well, my friend, you're in luck. So all you have to do, really, I just realized, was just put the sprite closer towards the camera. That's all you got to do. The problem is that pixel size thing I mentioned. Well, yeah, I have to recalibrate the pixel decimal place of the size to make it integer scaled again. But yeah, you might be wondering, oh, what about shadows? What if you wanted to cast a shadow? Well, I would just put an invisible sprite that doesn't display, but it still casts shadows. So we can kind of get like making it feel like it actually is physical while also not colliding with the walls, but also it's looks like it's there. I also had to move the camera because the other problem is that you kind of are a little bit off center, just the way it works kind of thing. But yeah, this is kind of like my weird workaround solution for that kind of stuff. But I think that's all that is. I think that's it. That's basically the video for now. I'm probably going to work on the actual level design, the level creation process. I was going to work on cutscenes, but I realized that I need to figure out what the location is, and even what the story is. The last devlog, I figured out the story, but I recorded this footage before I did the last devlog, if that makes any sense. So I'm kind of doing all this in tandem, but yeah, the next video is probably going to be a level creation, but that's why I know that. Anyway, see you next time. I don't know how to sign off, so that's all you get. You can leave now.